Okay. So last time we were talking about screw axes. And we gave it the symbol, what was it? NM. Okay. NM, where what does the N stand for again? Yep, a C sub N rotation. And then what does the M, like what significance does that get us? M divided by what? N, and that's a translation. And we just did a C2, or excuse me, a 2-1 screw axis. And I said we could draw symbols like this to indicate a 2, and then I put one like that, but we could also have a different rotation. We could go clockwise or we could go counterclockwise, right? Typically, which way is it? We're going to go, let me think about that. Which way do we want to rotate? Goes counterclockwise is convention, I believe. Yep. So beyond a 2-1, these don't really matter because we're rotating 180 degrees. But for the other screw axes, they do matter. So beyond a 2-1, the other screw axes there we go. Axes, 3-1, 3-2, and so on, are chiral. What do you know about chirality? Not much. That's an orgo problem, right? Chirality means there's a handedness, and it means you can rotate light in certain planes, or if you reach a chiral system, it will rotate light in certain directions. That's why when you look at a crystal sometimes and you rotate it, it looks different. It actually has to deal with something called birefringence in lining those rotated light planes with one another. So that's how sunglasses work in some cases. They have certain slits that prevent things from going through. But crystals, in most crystals inherently that have different symmetries and any that have screw axes, can actually rotate and make light cancel out through them. So if you ever get really bored, do you ever TA for Dr. Pianka's earth science class? Okay, you can actually, does anyone have access to a microscope? So if you get access to a microscope and you put a crystal, I'll find a YouTube video of it, you put a crystal on there and you rotate it, you can watch the crystal go see-through to black, back to see-through again, because you're looking at different planes. We're going to talk about those planes in a little bit too, but before we get there, let's show how, for example, a 3-1 and a 3-2 screw axes, how they are chiral. So 3-1, this is going to be right-handed, meaning if you were to go to pick it up and you curl with your right hand, it's going to curl the same way in that structure as opposed to the left-handed way. Okay? Yeah. Okay. We're going to indicate a couple of positions. We'll use red to indicate where those positions are in this system. You want me to use a dashed line or a straight line? So we need to divide this thing up. This is the unit cell edges. This is at position 0. This is at position 1. Since we have a 3-1 screw axis, what are we going to be translating by? Yep, so what do I have to divide this up to then? Yep. So I have to have 1/3, that looks about 1/3 to me, and then 2/3. Okay. We're going to have our original starting position here. Boop. Actually, we'll fill the dot in. Okay, I'm going to draw the imaginary one in orange as we rotate this thing. Okay, we have a 3-1 screw axis, a C3. What does that mean in terms of the number of degrees I have to rotate? 120. And remember, we go counterclockwise, so given the plane of the board, which way are we going to go? Into the board. We're going to go into the board. We're going to rotate 120 degrees. That's where our imaginary one is. 120 degrees. We're going to rotate it. And up at the 1/3 line, we're going into the plane of the board. Like that. Okay, we have to do another translation of a third, followed by another 120 rotation. Where are we pointing now? Out towards us. We're going out. Then we translate again by a third, and where are we going to end up? Back where we started. Okay. Now, let's try and draw on the side how this loop looks. So basically, we're spiraling like that, right? That's a right-handed spiral. Again, you point your hand in the direction that it curls, and it lets you know if you're using a right hand or a left hand. I gotta take. Like DNA? Yes, this is exactly like DNA. Oh, this makes a lot of sense. Yes. If you have to look at DNA ever, by which way it rotates, it zips through space, which way does DNA go? I think it's right-handed. It's all right-hand, so it's super irritating when you see left-handed ones in like pop sci art. It's like one of those things. It's like seeing a carbon with like 5 bonds to it, or an oxygen. Yeah, Texas carbon. I've learned that too. It's a good one. Okay. Now, we need to indicate which way this is spinning too. So what symbol would we draw for a C3? Yeah, we would draw a triangle. Okay, and we want to indicate the pad wheel nature of this thing and which way it's rotating. So we would do this to indicate that it's spinning in a right-handed direction. Let's draw the left-handed one next. Okay, we used red. So here's our 0 and our 1. We're also going to have 1/3. We're also going to have 2/3. Here is our screw axis. And here is our original starting position. Oops. There. 0, 1. Thank you. That would have been way worse. Okay. So now, 3/2 screw axis. Where are we translating to? 2/3. So we're going up to this guy, right? What's the angle we're translating? Yep, 120. So up to the 2/3. Am I in the plane of the board, out of the plane of the board? Pointing out towards us? Remember, we got to translate 2/3, then do what? Rotate by 120, right? So we're still doing it in the same direction. We will get there. But we got to do the symmetry operations in order of what they state. So we're going to be in the plane of the board. We're going to rotate 120 degrees. And where are we going to go? The 2/3. Okay. So we're in the back. Okay. We translated 2/3. We got to do another 120 rotation, right? But we have to do a translation first. We're at 2/3. We translate by 2/3. What are we going to go up to? 4/3 or 1 1/3, right? Okay, that is in the next unit cell. If we go up, so we've hit 1, we still have a 1/3 left. Where are we going to actually be at in our original unit cell? We're going to be at the 1/3, and where is this guy going to point? Yep, it's going to point out towards us. And we've rotated by 120 degrees. Now we translate again. How much are we going to translate by? 2/3. What position are we going to end up at? 1 or 2, actually, but 1 for reflections. And we rotate 120 degrees. Where are we? Back at the start. Aiden, does that make sense now? Because you wanted to translate this way, which is true. You could do that and jump up to here. Yeah. That's completely okay. Whichever way you like to do it. I like to do it in terms of the operations that are set so I don't screw things up. But if you realize, hey, if I go this way, that's the same thing as a translation in the next unit cell. That's okay.
So a right-handed one would be the opposite, basically?
Yeah. So now, triangle symbol, we need it to point the other way. So, boop, boop. And apparently you have to add those sounds to it to make it work too. So this is a 3-2 screw axis. This is a 3-1. Okay, let's draw the resulting structure. Shit, I drew the wrong. No, I did it right. Did I? I have to draw a left-handed one. Is that going to work how I want it to? Yes, it is. Okay. Sorry. Okay. I got to come out. And I'm just connecting the points. So this one would be a left-handed one. What I'm doing, am I okay to draw on top of the pictures right now? That is the same. I need to go that way. There we go. Okay, can I draw on top of the pictures to make this easier for me? Okay. So we're connecting these points, right? Like that. This one. I didn't draw it very symmetric. But you can see how there's a different screw axis there, right? And a different handedness to these. Do you guys see it or not really?
Wait, for the first one, you looped it inside the thing.
Looped it inside the things? Oh, I'm trying to go the pattern by which the shortest distance to them. So since this one's going in the plane of the board, that thing is actually going that green line is going into the plane to reach it. Okay? It is not drawn very well. The important point of this one is, could you represent it this way with a little, I don't know, antennas that we have drawn here? And could you indicate a difference between the two? That's the important point. Questions about this one? Lily, do you have a question, or you just mess them? Yeah, this one can go like that. This guy can go like that.